Everyone, today we're going to continue learning about redox reactions and practice what we've already learned. So, just to review a little bit, here we have copper and zinc. Identify what is being oxidized and write the half reaction. So again, figure out the oxidation numbers. And so we're looking for an increase in oxidation number. So zinc goes from 0 to +2. So for the oxidation half reaction, we've got zinc becoming zinc +2. Remember, we want to balance the charges by adding electrons here. So 2 electrons will balance out that +2 charge. And that is the correct half reaction. And again, the electrons will always be on the right side for oxidation. Okay, oxidation is loss of electrons. Okay, similarly, we can identify what's being reduced. So copper is going from +2 to 0. So we're going to write our reduction half reaction. So again, to balance this out, because this has an overall charge of 0, I need 2 electrons on the left side here, right, to write this half reaction. And again, we're looking for a decrease in oxidation number. That's literally what reduction means, right, to make something less. So reduction is the gain of electrons. So this copper is gaining 2 electrons to become copper metal. Now, here are new key terms here. Oxidizing and reducing agents. So the oxidizing agent causes oxidation of other substances. It's the chemical that is being reduced. Okay, so we want to look at the reactants here. Specifically, the chemical that was being reduced, we just said in the previous slide, is copper +2. Meanwhile, the reducing agent is the chemical that's being oxidized. It causes other chemicals to be reduced. So you can kind of think of these as opposites. When you see the word agent, right, it's the chemical that's doing the opposite. So the reducing agent here is zinc, because zinc is the one being oxidized. A little confusing, I know, but if you just think opposite when you see agent, I think you'll be able to figure it out. Okay. So let's try an example, practicing what we've learned. Write the balanced oxidation reduction half reactions. So again, start by giving oxidation numbers. The charges here are the same as the oxidation numbers. Write the balanced oxidation and reduction half reaction. So oxidation and reduction. So here I see sodium going from 0 to +1. The number is increasing, so that tells me that it is being oxidized. It's losing an electron, right? When it loses that electron, it becomes +1. Meanwhile, magnesium is literally being reduced from +2 to magnesium 0. Now to balance the charges, I'm going to need 2 electrons on the left side here. Now these are almost correct, except I need to balance both of these. So what does that mean? I want the same number of electrons on both equations. So I'm going to multiply everything here by 2, and I get 2 Na, 2 sodium ions, and 2 electrons. And now this is my correct final answer here. Okay. Those are my balanced half reactions. What is the oxidizing agent? What is the reducing agent? So remember, the oxidizing agent is whatever chemical is being reduced. And again, we're always looking at this side for that. So here, Mg+2 is being reduced. It is the oxidizing agent. It's causing sodium, right, to become oxidized. Meanwhile, sodium is causing magnesium to be reduced. Therefore, it's the reducing agent. Okay, so when you see the word agent, just think opposite. Okay, if this is being oxidized, it is the reducing agent. Okay, I know I'm going through this quickly, so feel free to pause it, go back and rewatch it if you need to. All right, the next new topic we're going to learn about is called an activity series. So take a moment to copy down this activity series, but it helps us predict the behavior of metals. So this table tells us which metals are the most reactive on the left side. We've got these chemicals versus the chemicals on the right side, which are the least reactive. So things like silver and gold are not very reactive, right? They're able to keep their shine and they don't react with the air or water. And that's partly why they're so valuable, okay? When we say most reactive, those chemicals tend to give up their electrons easily and undergo oxidation, whereas chemicals on the right side, the least reactive chemicals, are more likely to undergo reduction, right? They're more likely to gain electrons. So, why is this useful? Well, it can help us predict whether or not reactions between metals would occur. Okay? The more reactive metals on the left side should be the ones that are oxidized. Okay? So in this first reaction, it's asking, would the following reactions occur? You just have to put yes or no. So aluminum is becoming aluminum plus 3. So let's look at that. Aluminum's here, and then we've got copper over here. So aluminum, right, is more reactive, and it's also being oxidized. So the more reactive metal should be oxidized. If that is true, then this reaction is likely to occur. Okay? So here, the more reactive metal is aluminum, and it is being oxidized, so therefore this is likely to occur. In our second example here, we have nickel and sodium. So let's find those. Sodium is here. Nickel is here. Which chemical is being oxidized here? So I see that nickel is going from 0 to plus 2. But according to my activity series, right, sodium is going to be more reactive. Sodium should be the one that's being oxidized or losing its electrons. So this reaction is not likely to occur because we should be seeing sodium becoming sodium plus 1. Lastly, we have lithium versus zinc. I'll use a different color here. Lithium, one of the most reactive metals, and zinc is over here. So lithium is indeed being oxidized. It's going from 0 to plus 1, right? The number increases, and it should be because it's more reactive than zinc. So because the more reactive metal is indeed being oxidized, we say that yes, this reaction is likely to occur. Okay, so that's how we use an activity series. Feel free to look at my explanation on one of those practice problems to help you out with this. And yeah, that's it for today's lesson.